This is a quick summary before the full video. OffGrid Garage did a review of the Pathfinder BMS, and he had a lot of problems with it. I recorded a full reaction to his video, which is very long. I think it runs for an hour and 10 minutes. The biggest problem he started with was that he had an outdated or obsolete copy of the Pathfinder Datasheet. His BMS came out of the box with version 0.3 firmware, but his datasheet is only good for version 0.221, and there's a lot of new features and changes added in between those two versions. If he had had the right datasheet to start with, he would have avoided a lot of the problems seen in the video. To add to that, my website been hacked somehow and was completely down and unavailable, which means that he was not able to go in and download a fresh copy of the datasheet. I've since gone and updated the datasheet again to address some of the concerns in the video. Okay, to get a fresh copy of the datasheet, what you need to do is go to overkillsolar.com, and then you can either go to the Pathfinder product page, or you can go right here to support and downloads. And the first thing on that page is going to be the Pathfinder BMS datasheet. Just click that, and it'll bring up the most recent copy. Every time I do a firmware update with a new feature or a bug fix, I also push out a new copy of this datasheet to the same file. So make sure that your firmware version here at the top of the page matches the firmware that's running on your actual BMS. I've added that to every single page, and then if you go all the way down to the bottom of the datasheet, you'll find the flow chart, which helps you navigate the OLED screen on the front of the BMS. And I added an extra note here: make sure your document is up to date for your firmware version. That's going to eliminate a lot of confusion, because if I change some screens here and you have the wrong version, you're going to be lost.
I'm a bit lost.
The datasheet is now 57 pages. The one that he was using was only 47 pages, so that you can see that as I continue adding features, the datasheet gets longer and longer. Moving on. Okay, so the next major thing that Andy had a problem with was the logic for the balancer operation. How it works now is that when you set the balancer start voltage, all of the cells have to be above that voltage before the balancer will start balancing. And he thought that is backwards and wrong, but that is defined by the chip that actually runs the BMS functions. It's basically a complete BMS on one chip. So if you had a standalone or embedded BMS that doesn't need a user interface, then this is the only chip you would have, and you would burn the settings into it. But it only has one mode of balancing, which is the way it works now. If I want to change the operation, which I might do, and I need your opinions, put a comment in the description if you agree with Andy that the balancer operation is backwards. I just didn't think that we needed to change the default logic that's built into that chip.
That makes no sense at all. Which makes no sense.
Okay, so he also complained that the balancer was getting too hot. In his testing, the thermal camera showed that the bottom of the BMS was getting up to 60 degrees Celsius, which I disagree. I don't think that's too hot. I mean, it's a passive balancer, and the only way it works is by converting the excess energy into heat, so of course it's going to get hot. I found reviews of gaming laptops that get up to, this one gets up to 57°C on the bottom of the laptop, and that's the part that they expect you to sit on your lap. Now, I agree that's too hot for a laptop, but I don't think it's too hot for a device that's meant to turn energy into heat. The next thing that was a big problem was the learning cycle, and this goes back to having the wrong data sheet. I have already added an alternative, much more simple state of charge calculation that's enabled by default. So the learning cycle that he was playing with is a built-in function of this extra chip that we added. It's called a fuel gauge chip. When I first started designing the Pathfinder BMS, my plan was to program my own state of charge calculation, but the programmer I hired to help with the firmware, he said, well, there's a couple different dedicated chips out there that do this complicated state of charge calculation, so what if we just buy one of those chips and then we don't have to do all the coding to make it work? So I said, okay. I added the Z100 chip in, and then by the time we got around to setting it up, it was basically too late to take it out of the design. We'd already figured out the hardware design, and that's when I realized that there were so many bugs in that chip's firmware that it was really difficult to make it work. Even so, I left its functions enabled to see if I could get some feedback if anybody had better luck with it, and that was obviously a mistake. So at this point, I'm going to give up on that chip, and I'm going to remove all of the learning cycle functions that are related to it. For now, I'm keeping the actual physical chip because it has a higher resolution current sensor than the other main BMS chip. So if we go back to the newest copy of the datasheet, we'll see here the headings called State of Charge Measurements. The Pathfinder BMS uses multiple semi-independent algorithms to track and calculate the state of charge. And on this menu, you can see that this new algorithm that I added is called Basic SOC, and it's selected by default. You can also go back and select the Z100, and what that does when you change this selection, it just changes the data source, so it changes what data you're going to see. The underlying calculation keeps running for both of these, regardless of which one you select. This goes on to describe the operation of the basic SOC. This uses a simple method of resetting the capacity at the high and low voltage points and then tracking coulombs in between the reset points. When the BMS is first set up or has a total reset, the state of charge is initialized at 50%. To learn the capacity, discharge the battery until at least one cell is below the low voltage threshold, and then fully charge until one cell is above the high voltage threshold. And you don't have to do this all at once. Every time the voltage level hits the high or low thresholds, the algorithm will reset to either 0 or 100% as appropriate, and it also updates the confidence level. If you've done a full cycle from 0 to 100%, the algorithm will report 100% confidence. And then the longer or the more charge cycles that it accumulates in between those high and low set points, the more the confidence level will drop over time until it actually gets a 0 or 100% reading by voltage. After that, it goes on to describe the Z100 learning cycle, but I added this highlighted note. Note, this is optional, and I plan to remove it. A couple other concerns and suggestions that I'm going to take up and add to the next firmware update. One, he would like to see a web interface. So once it's connected to Wi-Fi, it tells you its IP address on your local network. If you open that IP address in a browser, right now nothing happens. I plan to add a web interface. You'll be able to open or ping the BMS in any old browser that's on your network, and you'll be able to at least see the basic info. If I was to make that interface fully featured like the mobile apps, then that's going to take a lot longer. Second thing, he was annoyed because every time you go to the settings page in the mobile app, it makes you put in the Bluetooth passkey again.
Oh, it wants the passcode again. Jeez.
And I did that so that if you have a tablet or a phone that's always on that you're using to monitor your BMS, like a lot of people will stick an old tablet to the wall. So I did that passcode every time in case kids were playing with the tablet, so you can't go to the settings page and accidentally change something. What I'm going to do is I'm going to add a Remember Me button so you can optionally save the passkey for when you go back to settings. He was complaining that the navigation on the small screen here was not very intuitive, because if you go to the Wi-Fi setup, or if you go to the Wi-Fi status screen, you can't jump straight to the Wi-Fi setup screen.
Wi-Fi disconnected. Okay, let me connect. Can I not connect to the Wi-Fi here somehow? No? Yes?
You have to go back to the datasheet and look at this map to figure out, how to find it, or you can just click around. So anyway, all I'm going to do is just change the button navigation so that if you click on the Wi-Fi status, it'll jump over to the setup screen. And we'll do the same thing with the MQTT status screen. When you first start up the BMS, I'm going to add a little pop-up that tells you now would be a good time to calibrate the null current. And to go along with that, I'm going to increase the deadband on the current sensor. So presently it was set at 12 milliamps, which I'll admit now that's too low. 12 milliamps is really within the noise floor of the current sensor. So I think I'm going to change it to 50 milliamps, and below 50 it'll just always say 0. And that's normal in analog circuits to have a deadband around 0, because it's going to drift. It'll drift a little bit with temperature and time, and so it's normal to have a dead band where it only shows 0. Beyond that, he started adding in some anti-American political commentary, which I don't see how that's relevant to the BMS. Oh, and then he started complaining about the price of the BMS. He was showing price comparisons on websites like AliExpress, where you're logged out and it shows you this ridiculous welcome deal that's like 70% off. So he's showing me a BMS where it says the normal price is like $350, but the welcome deal is $100, 70% off, and as if that's a fair price comparison, and I don't think that's a fair comparison at all. So anyway, enough of my complaining for now. If you really like the sound of my voice, keep watching, because there's another about an hour and a half of me reacting to Andy's video as it goes. Thanks for watching. Let me know your opinion down in the comments. I want to know if you agree with Andy about the balancer logic, and if most people agree, I'm going to take the time to change it.
Overkill Solar. Steve, well done.
This is going to be a reaction video to OffGrid Garage's review of Overkill Solar's new Pathfinder BMS. I'm Steve. I'm the electrical engineer, and I'm the owner of Overkill Solar. So the first YouTube channel to review the new Pathfinder BMS is OffGrid Garage, run by a guy named Andy. I like his videos, and he's reviewed the old JBD BMS that I started selling. He's the first one that posted a YouTube review of the new Pathfinder BMS, and apparently he didn't like it. I'm going to go ahead and watch his two-part video review and comment on it as we go. That's my sticker. Free cable ties, bits and pieces, terminal board, and the BMS.
And it says up here, this is the very first BMS designed and manufactured by Overkill Solar. We have been working on this design for several years now, and we have been 100% focused on it, since our old BMS supplier pulled the plug on the old models.
Yes. If you don't know, what happened there is I started out distributing 3 different BMSs that were made by JBD, which is a Chinese company. And the main thing that I did, besides just importing them and having them available, was I wrote all the documentation. I wrote the user's manual, and I hired a programmer to create a new mobile app for it, because the only existing option for Android users was this very poorly done purely Chinese Android app that was really difficult to use. So we programmed the replacement for that, and we documented the BMS. And that went pretty well for a while, for about 4 years, and then my contact for JBD told me that they are discontinuing making that model, or all of the models that I was buying. And I could not convince them. Well, for a couple months I convinced them to keep making it, but they said they just weren't going to do it anymore. It was a combination of they had new models coming out, and the components for the old ones were becoming more difficult to source and more expensive. One of the things was it had an STM microcontroller in it that became really hard to get during COVID. So they wanted me to buy a couple different new models. All the chips in them were like third-tier Chinese stuff that had no documentation, at least no documentation at all in English. So I didn't like that. And the worst part was they had, unlike the old ones, which had a Bluetooth module that plugged in, these new ones had built-in Bluetooth without an extra module, which sounds fine, except that they had absolutely no security features built in. There's no way to stop an unauthorized connection, and near as I could tell, once you had set it up with the Chinese app, there was no way to stop it from sharing data back to the manufacturer. There was no way to shut off the radio power either. I asked them if we could customize the firmware with a kill switch for the radio power to stop connections, or if we could customize the security, and they just weren't interested. They also weren't interested in improving the terminals. They have for some reason the Chinese have a tendency to use very small threaded terminals like M5 or M4 for 150 amps, and it just doesn't sit right. So I had to decide to just abandon the JBD models and finish working on the Pathfinder BMS, which we'd already started.
Yeah, you may have seen it on the Overkill Solar website. There is no Overkill Solar BMS anymore as such.
Right.
No redesigned or upgraded JBD BMSs anymore.
Because they don't make it anymore.
Quite a while. And now the Pathfinder BMS is the only BMS they are actually selling.
Yes. Finishing this took much longer than I ever expected it would.
And thank you very much for this great sticker. It looks amazing.
You're welcome.
Guys, welcome back to the OffGrid Garage here in sunny and hot Australia. So, and let's have a look at the hardware first. What do we actually get with the Pathfinder BMS from our friends at Overkill Solar? So this BMS consists of a stack of 3 PCBs. Actually, it's 4 PCBs. If you look very closely, you can see this is a double layer PCB here. And the bottom layer, let me bring on some light here. And the bottom layer consists of hundreds, I would say hundreds of SMD soldered resistors.
I think it's 470.
This is the passive 1 amp balancer.
And there are fuses in there too. Actually,
and for heat dissipation
PTC
purpose,
thermal fuses.
This is a double layer PCB down here. It is just to get rid of all the excess energy from the passive balancer. The PCB in the middle contains all
the very bottom layer on the balancer board is actually just there to it's there for mechanical stability. The standoffs are soldered to that board, and then the board with all those resistors is pressed on top of it, and the bottom board has no copper on it at all, and it protects the traces on the bottom of the balancer board. Here are the 2 boards. This is the actual active part of the balancer board. It has, if I remember right, there's 470 load resistors. There's a whole bank of them for each cell, so that's cell 1 through cell 16. And then each one of those cell banks has 3 PTC over temperature fuses, and then just some transistors to switch the power. There's also an activity light at the top, and then that gets pressed onto this board, which is purely mechanical.
You can see a whole row of MOSFETs down there, and interestingly they don't have any heatsink, right? They are just air cooled. And this
actually, that's not quite true. I spent a lot of time and went through a lot of variations setting up the geometry of the MOSFET array here. I actually went to a lot of trouble to connect the MOSFETs in a common source arrangement, and what that does is it allows me to solder the main body of the MOSFET, which is where all the heat dissipation comes from. It's the lowest path of thermal resistance out of this chip package. The top of the package is actually just a plastic cap, and most designs use thermal paste and an aluminum heatsink to pull heat out of the top of these chips, but that's barely, honestly, it barely does anything. So these ones are actually soldered to a big copper plane on both sides of this board. This whole thing is a solid copper plane, actually on both sides, and the heat gets to go straight out of the bottom of this chip package into the copper plane on both sides of this board, and so that's the heat sink. It's actually, the entire board is an integrated heat sink, and I tested an additional heat sink on top of these chips, and it made maybe a 1% difference. It wasn't worth doing it at all.
An interestingly shaped and laser cut PCB here at the top contains the display, all the buttons, and also the ESP32 chip. This is right down there. So obviously we have the two M10 terminal studs left and right. One connects to your battery, most positive, and the other one connects to your load and chargers. We've got connections for Bluetooth and Wi-Fi, as well as a USB-C connector, two connectors for temperature sensors, a wake and reset button, the connector for the balance cables. On this side we've got two LEDs for charging and discharging, and a discharge switch. And if you connect these two pins, discharge will actually turn off. This is especially very useful and handy if you frequently connect inverters to the BMS. You just close the switch between these two contacts, discharge is off, you connect your inverter and turn the BMS back on. More about this feature later. Then we've got two more LEDs here. One is an overload and the other one is the active pre-discharge light. Yeah, and of course here at the front the tiny OLED display, 4 buttons for directions, OK, yes, no or back button. And an interesting feature is this connector here for the balance cables. So at first glance it looks like a normal terminal connector. We've got cells from 0 all the way up to 16, and once connected it plugs into the BMS and connects all your battery cells and terminals to the BMS. But on the second look it says, hold up, wait a minute, did you press test on the balance connector? Red LED indicates fault that can let the magic smoke out. So they are actually warning that you have to check your balance cables, as you usually should with all BMSs anyway. But this one is a very special terminal adapter here. It has a little test button over here, see that? So once you connect your battery and you press the test button and you get a red light, you have connected your battery terminals in the wrong way. But if you get a red light here, something is wrong, don't plug it in, otherwise the magic smoke comes out of this BMS.
I was able to make the main board resistant to a lot of different faults. A common one is plugging the connections in the wrong order. Like if you plug BC16 in first before BC0, which is ground, the chip could be damaged. But I was able to fix that. The only thing that really can't be fixed is swapping balance wires. So you would have a negative voltage between two cell voltage inputs where they're just not protected against that. And the solution we found out was this simple indicator circuit on the terminal board. So if you have balance wires that are connected out of order where there's a negative voltage, the corresponding red light will come on, and you know to go back and fix that before you plug it into the BMS. Unfortunately, a few people, I think actually only maybe 2 people have done it anyway. But that's okay. They got new ones. They got a free replacement. The only part that I still don't like about this terminal board is that the exposed connections on the bottom are vulnerable to shorting out on the workbench. I've had to replace some of these terminal boards because the customer was connecting up their wires and they sat that board down on something metal and crossed two of the wires, and that just burns the traces out of the terminal board. Good news is those are cheap and easy to replace. But I haven't thought of a good way to protect those exposed pins on the bottom. And the connectors are not available in a surface-mounted version. They have to have the through-hole pins.
Any of the other BMSs so far? Yeah, so there you have it. This is basically everything we have here. I like actually the fact that I have printed the manual how to connect this BMS to a 4S battery as an example on the back of the BMS, so you can never lose it. Designed in Florida, March 2025. Programmed in Canada, eh? Made with parts from cheaper countries.
Sure
Super
is.
rare these days that you find a product made in the US with a Canadian flag on it. Okay, let's have a look at the 46-page long documentation for the Pathfinder BMS.
While I was starting to edit this, I went back and noticed that Andy is using actually a much older version of the datasheet than what his BMS even shipped with. He got one that shipped with version 0.300, and he's using the datasheet for version 0.221. And there were some major changes in between there, and I think he would have had an easier time if he downloaded a fresh copy of the datasheet. With regards to the learning cycle and the SOC calculation, there was a major change in between there that he doesn't have any documentation on because he's reading the wrong version of that datasheet.
I mean, come on, we're always complaining that manufacturers of these BMSs don't provide any documentation, and now they are doing it, 46 pages, all written in perfect fine English, American English, and now we are saying, oh, 46 pages is far too long, far too long. It's, I've got a summary here, it won't take long. So obviously the features, 3 to 16 cells, minimum 7
It's not too long. In fact, it's getting longer.
volts up to maximum of 64 volts, yeah? 170 amps continuous duty current rating. Advanced state of charge tracking, yeah? Very good, very good. Built-in OLED user interface, do-it-yourself focused design with positive side switching.
I feel like that's some foreshadowing. One of Andy's comments said he had trouble with the learning cycle for the state of charge tracking, but we'll get to that.
Bluetooth, Wi-Fi, USB interface with free monitoring apps. This BMS works with the usual Overkill app 2.0 or later. So it can operate battery voltage up to 64 volts, 170 amps, 100% duty cycle. It gets over-the-air firmware updates. Yeah, this is very nice. It also connects to Home Assistant through MQTT and has several status LEDs, which you have already seen. So here it says again, base plate. This is the bottom layer basically with a 1 amp passive balancer. Main board. It has the Texas Instrument, whatever that means, chip, fuel gauge, chip, MOSFET. This is the MOSFET layer, and then the top.
Texas Instruments is the manufacturer of the chips. It's an American manufacturer. Of course, they also make most of their stuff in overseas.
Layer is the one with the ESP32 microcontroller, USB, Bluetooth, and Wi-Fi. And of course, as we have seen, it has this balance wire terminal board, it's called, with a test button. So that's a cool feature as well. Alright, I went through all the 46 pages already. I've got a bit of a summary here. So these are all the drawings and everything. Yeah, there is a DIN rail mount available. It basically clips into these ears. So there's nothing in the box here. Obviously, this is an optional feature this BMS has. 170 amps at 22 degrees Celsius. As I said before, that's a 100% duty cycle. everything warmer to be determined. So obviously the current goes down the hotter the BMS gets. 400 amps maximum surge current for 10 seconds and 1000 amps short circuit detection point. Total resistance.
Actually, the MOSFETs don't have any trouble handling 1000 amps. The current limitation on the complete BMS assembly is just based on temperature. You can, like, each one of these has a nominal rating of I think it's 600 amps each with with adequate cooling. So there's 12 of them in 2 banks, so 1000 amps for a few seconds, or in this case it's only going to be a few microseconds, is not a problem at all.
Resistance all FETs on 0.3 milliohms. Balancer current mainboard 43 milliamps plus the passive balancer on the bottom layer board of 1 amp or 1.17 amps at 4.2 volts for lithium ion batteries. And here on the balance board it is 1 amp passive balancing. So the default setting is maximum of 4 cells can be balanced at the same time. This is for heat distribution, because as we have seen there's no heatsink in these boards here somewhere, anywhere. And
the whole assembly is a heatsink. It's integrated.
And the balanced start voltage for lithium iron phosphate is a 3.1 volts, which is far too low. I hope we can change this setting later in the parameters somewhere.
Yes, you can.
A high current active balancer option is planned but is not yet available. So there might be something coming in the future for this BMS as well with an active balancer.
It just takes time.
Okay, cell count, setup and balance. So we've got an M10 by 1.5 terminal. These are these huge massive studs here, and somehow they are pressed onto the PCB, which gives them a higher strength than anything else, it says here. Yeah, and
I tested these press-in terminals pretty thoroughly. They perform way better than a soldered terminal. When you press these together, the copper board material basically welds itself into the brass terminal material, and they will not come out, and the contact resistance is quite a bit lower than a soldered connection, no matter how big it is.
Then we come to the interesting part here, state of charge measurement and learning cycle. So this interesting feature with this BMS is when you connect it the first time to your battery, it doesn't know anything about the state of charge. But when you start charging and discharging it, then it actually displays a confidence level of state of charge percent. And it says this here something, here in the display, SOC confidence 100%. So it is 100% sure that you are on 100% at the moment. Well, this is pretty clear then. So it gives the estimation a bit of weighing. And obviously, even without this learning cycle, it learns over time how your battery works, how much power goes in, how the voltages go up and down, and it gets more confident the longer you use it. Yeah,
that is the
but it's really
purpose
recommended
of the
to do this
chip,
learning cycle here. So it also says here in the display that the learning cycle has started, and the chemistry is lithium iron phosphate, obviously, and then it has a lot of other parameters. I'm not sure how this information all fits on this tiny display. I mean, this is big as 2 of my thumbnails.
It's tough.
And it has some other indications here on this display, an ITEN impedance track algorithm enabled. The last open circuit voltage measured can be used to update measured capacity. Resistance table updates are disabled. Full charge has been detected and state of charge has been set to...
All of this on this page comes straight out of the documentation for the BQ34Z100 chip. That's the extra chip that's only there to track state of charge. And basically, I regret choosing this chip. I didn't figure out until it was too late that it's it's defective. Texas Instruments, who I used to think had like the top shelf products and top shelf documentation, they really dropped the ball on this chip, and it was too late to take it out of the design. I think my next move is going to be to basically delete all of the functions that chip handles. And the only reason I'm probably going to leave the chip on the board is because it has a more sensitive or a higher resolution current sensor than the main BMS chip. There's two chips on this board. This one here in the middle, that is the main BMS chip. That actually, it's like it's a BMS on a chip. You could program this and burn the programming in and let it operate standalone as a BMS if you didn't need a user interface. In fact, that is how it's used in a lot of products, especially integrated BMSs. And then we added this other chip here. That's the Z100 chip that's supposed to be tracking the state of charge. It just, unfortunately, its firmware, which I can't change, it's the Texas Instruments firmware, has so many bugs and the documentation is so poor that I actually regret even releasing the BMS with its functions enabled. But the good news is I can just shut it off in software, and I think that's what I'm going to do, because I can see what's coming here. Andy's going to spend half his life trying to make this work, and it's probably not going to work for him. I left these functions enabled in the hopes that we could get some more information and figure it out how to make it work reliably. But I think it's time to give up on it. And that doesn't mean that the state of charge is going to be any less accurate, because that ESP32 controller is perfectly capable of running its own state of charge tracking algorithms. In fact, it can do multiple different algorithms all at the same time. All it needs is the current and voltage measurements as inputs. And in fact, I'll talk about it more later, but that is what I've done in the most recent firmware. I added another state of charge algorithm that only runs in the user interface controller and doesn't rely on the conclusions drawn by that extra chip.
200%. The rate of change in voltage is low enough to record an open circuit voltage measurement. Rest. Okay, whatever this all means. Yeah, so, and the learning basically between...
Yeah, I'm sorry, it's confusing. I should have deleted this whole section.
0% and 100%, it uses the discharge termination voltage. At the beginning I thought this is the over voltage protection, but no, this is a different setting, obviously a different parameter, right, which we can hopefully set ourselves. And once it reaches the discharge termination voltage, it goes to 0. And once it reaches the charge termination voltage, it goes obviously to 100%. Yeah, here you can see it again. Charge termination voltage 100%, and discharge termination voltage 0%. Yeah, 3 volts, 3.5 for lithium iron phosphate. At this stage, I'm not sure if we can change them, but I hope we can. So here it says the state of charge measurement is reset to 0 when the discharge termination voltage is reached, and is reset to 100% when the charge termination voltage is reached. Yeah, these values are not adjustable as of the first firmware release. So obviously it handles it only between 3 volts 0 and 3.5 100. Well, I never charged to 3.5 volts, so this BMS would never reset to 100%. But we will see, maybe we have an upgraded firmware already here and we can adjust these parameters. We will find this out later. Okay, and then we have the Wi-Fi connectivity here. So the BMS comes with Bluetooth and Wi-Fi connection. If you have Wi-Fi enabled and connected to your home network, it will automatically download over-the-air updates. If you don't want to connect it to Wi-Fi and use the automatic over-the-air update, you can also download the firmware and use the USB-C connection on the BMS to update the BMS manually. You can turn off the radio, but I think it is for both Bluetooth and Wi-Fi at the same time, so you cannot select to have one on and one off. It's all or nothing.
It's the same radio.
With the over-the-air firmware updates, you can select auto update, always ask, or never check. Stable only or beta. Yeah, it connects to the GitHub website. Down here, yeah, that's the Overkill Solar GitHub website, and it downloads alpha, beta, or stable firmware versions. Then we have the MQTT Home Assistant connection. At this stage, I'm not sure what kind of entities it actually exposes to Home Assistant. So, and the BMS also comes with a pre-discharge function. It says here the pre-discharge circuit will engage when conditions have been met. It connects the battery to the output via a 12.5 ohm resistor and monitors the system voltage until it rises to a sufficient level to prevent a damaging inrush current, at which point the main FET array will switch on. I think this is what most BMSs have these days. They can determine if it is a short or if it is an inrush current into an inverter. LED indicators, as we have seen, wake, reset, status, charging, discharging. Manual output controls, you obviously can disable and enable the MOSFETs for charging and discharging. There's also a UART connector. It says somewhere the API is not yet available. Data logging, it can create a CSV file with all these information. And here all the parameters and all the settings again. Unfortunately, it doesn't say if we can change these parameters or which parameters we can change.
These parameters can be adjusted, like the balancer parameters can be adjusted via the BLE app or the USB app, but not the OLED. And that is something that I need to finish programming. It's just a matter of time. It takes forever to program menus and screens and keyboards on the little OLED screen. So eventually every single parameter will be accessible from either the mobile apps or the on-screen display.
Meters we can change. So we have to wait until we connect the BMS and find out ourselves. Interchangeable parts. This is a very interesting feature of this BMS. You can actually replace all these 3 different PCBs. So I've never seen that before. Okay, how to connect the balance wires, question FAQ, units conversion. And here at the end, this was actually a pretty cool site, the last page in the documentation. Just let me zoom out a little bit. This explains all the menus you can actually select through this tiny display on the BMS. And it walks you through, so you never get lost. You can always find yourself and then go left, right, up, down, OK, back. And it explains and shows you all possible features on the display here. So that's pretty cool, actually.
Yeah, Andy is using a different version of the data sheet than what I have here. So part of his problem may be coming from obsolete documentation, unfortunately. I update this data sheet every time there's new information and replace the file on the website. Anybody who's looking at this document should go download a fresh copy of it, just to be sure that you have the most recent version. And if you look up at the top, this one says applicable up to firmware 0.301.
And I must tell you, it was not as easy to connect this 4S lithium iron phosphate battery to a 16S connector. Because when
I thought I sent him a 4-cell terminal board in the package. I definitely should have if I didn't.
I started and connected everything, I put all my cells, cell 1, 2, 3, 4, as you usually would do, pressed the button, everything was green. Plugged it in and got this skull straight away. So something was not quite right with the cabling, but I couldn't figure out what
let me
we
see.
would do.
It should work the way it's connected.
pressed the button, everything was green. Plugged it in and got this skull straight away. So it's not super straightforward, but eventually it will work. All right, let's plug this one in and see what happens. There you go, green light, Pathfinder BMS.
Yay.
It says detected 4 cells, type lithium iron phosphate. Hang on, I'll switch to the other camera. All right, I think this is as good as it gets. It's very, very hard to record this screen here.
I know.
It's super glossy, you can see all the light reflections and not easy to focus with the camera. So it says now after connecting and turning on, detected 4 cells of type lithium iron phosphate. Is this correct? And then you press the OK button here on the right. Flashing. So it's loading all the parameters now. Initializing BMS. There we go. So if we press the down button, we can cycle through all these screens. And one of them should us, yeah, here we go. Yeah, and here it shows us only the 4 cells now because we have bridged all the other ones and it knows it's a 4S battery. And believe me, these numbers are even tinier with your bare eye. All cell voltages, sum, and so on and so on. A learning cycle. So we are on firmware version 0.3 stable. Built in July 28th, 25. Wi-Fi disconnected. Okay, let me connect. Can I not connect to the Wi-Fi here? Somehow? No? Yes? No?
Go back to the screen
Bluetooth status, none. I thought I can change these settings here with the buttons here as well, but obviously not. No, I cannot go.
Screen. You have to go.
How do I set up Wi-Fi?
Go back to the screen
Do you
map.
have to press and hold? Do I have to read the menu?
Yes, you have to read the manual. It's a tiny screen. You have to go back to... That's why I included this page in the manual, so that you don't have to guess at what screen you're on. He was in the home row right here, and you have to go a few notches over to the right until you get the Wi-Fi set up. And then you'll press OK and get the Wi-Fi setup screen where it lets you open the keyboard and put in your credentials.
Okay, you know what? Let's have a look in the app first. This is version 2 point something. So far all the batteries are showing up, which have a JBD BMS, but nothing saying Pathfinder. Scanning for devices. But it says here Bluetooth status advertising. So it should be, it is Pathfinder BMS. Okay, I'm very excited. Let's log in. Discharge under temperature, charge under temperature. Oh, okay. Because I haven't plugged in the temperature sensors yet. And we're already charging with 30 milliamps. How does that work? There's nothing connected.
Obviously you have to calibrate the current sensor. It's a very sensitive analog sensor. It needs to be manually calibrated. Obviously it does say that in the datasheet. The reason why this has to be done manually is because the user has to ensure that there is actually zero current flowing through the BMS. If it was to start this routine automatically, you might get a bad result if there actually is current flowing through it at the moment. So this is a documentation issue. I think it would probably be a good idea to have a pop-up message on the screen when you do a new installation that you should go perform the current calibration.
Gives us a lot of information here. Time to full, time to empty, state of health, charge under temperature, discharge under temperature count, and all the statistics. Okay, let's go to settings. What do we have? Pre-discharge configuration, balancer configuration, start 3.1 volts. Okay, can we change this to 3.45? Done. Yep. Then it prompts us up here, click to write to BMS.
I saw Andy's comments on the next video that he was having trouble with the balancer and it was shutting off when you go below 3.45 volts. Well, he just changed the balancer start voltage to 3.45 volts. If he had left it at 3.1 volts, he could have avoided the problems with operating the balancer. And he said earlier, he said earlier that he never charges his battery all the way to 3.5 volts, which I disagree with. I think he should charge it to 3.6. It's right there. Like 3.5 volts is right when you get into the area of 100% charge, but I would like to see it charged to 3.6 volts in order to get a good read on the state of charge and the actual state of balance. So anyway, this is one of the first problems that we're gonna, I think, run into later. I wish he would have left that at 3.1 volts.
Seems like it has accepted it. Okay, cool.
Yep,
you can change these parameters. Okay. Set idle current to 0. Yes, that's what we want to do.
Yes. It does take a little bit.
And now it shows 0. So there are a lot of questions I have now, because these are not many parameters. These are the standard, but we cannot set any charge termination voltage, for example, where the BMS resets to 100%. This all seems to be hard wired.
At the moment, those are hard
or
coded.
I'm not on the latest firmware version, which I cannot update either because the Wi-Fi does not connect. Alright, give me 2 minutes here. I have to do a bit of a reading in the manual again and see how to set up the Wi-Fi. And then we have to determine if there is a newer firmware which actually allows us to change a bit more settings than only these basic ones here.
Not yet.
Alright, I'll be back after the pfft.
It's
so
coming,
in the
but
minute
not
it
yet.
says under Wi-Fi, the Pathfinder can connect to 2.4 gigahertz Wi-Fi networks. Credentials are entered via the built-in screen. The Wi-Fi connection is used to check Overkill Solar's GitHub for OTA updates, if enabled, and for sending MQTT and QTT messages to Home Assistant, if enabled. Wi-Fi status disconnected. Yeah, that's what I'm exactly seeing. And set SSID, I cannot see that part, and all the buttons are not working. I've tried different combinations as well. I don't know how to enter the Wi-Fi status here. It doesn't say anything in the manual. So this is now the third time that bit of frustration kicks in with either the manual or the BMS or a combination of both. And if I have to contact the manufacturer of this wonderful BMS here, Steve, it is already too late. So for providing a 46-page document and I cannot figure out how to connect it to Wi-Fi, I'm not going to contact the manufacturer for that. That's an absolute fail. So actually from the main screen you have to press the button to the right here to go across MOSFET control, BMS settings, UI settings, and under UI settings you go down to Wi-Fi setup. Press OK. Set up SSID. Okay.
Alright, what I can do is I can change the screen navigation so that if you go to the Wi-Fi status screen on the first page, then it would let you jump to the setup page. I'm going to make a note to do that. So if you're on this Wi-Fi status screen and you click OK, then it will jump over to the setup screen, which is over here.
Set password. Oh, holy shit. Really?
What?
What? Connection fail? Why does it fail? Wi-Fi credentials
rejected. Because your password is wrong.
Oh, jeez. Amazing. Okay, we try again. Connect. Rejected again. And this time I made 100% sure this is the correct password. 110%. It even says the password down there. Oh, you can't see that, but this is my Wi-Fi password for this Wi-Fi SSID. And it doesn't connect. Okay, frustration. Oh, now it's connected. Okay, without changing anything. Okay, it's connected now. Perfect. All good.
Okay, I have no idea what
Okay, we can
was
go
happening there.
out of here.
Because I don't know what his
back.
password was, but I've never
And now
seen
we
that
should be able
happen.
to go down. OTA fail. ESP had a begin fail. Maybe Wi-Fi has no internet.
Yeah.
Oh my god. Alright. Wi-Fi. OTA updates. Always ask.
It says that when it failed
Radio
to
power.
reach the GitHub
Wi-Fi
server.
setup. Connected. It says connected. And the green antenna light is flashing up there.
Yep.
So I guess that's a good sign. From here we need to go over. No, there's no. Hang on. Over the update, ready, update firmware 2 version, blah blah, but it's not. But before it said it's up to date, right? That's the up to date version here. Then it says over the update, confirm. But obviously there is no newer version at the moment as this version 0.3. Okay.
So I have no way to tell what is happening with his Wi-Fi. I haven't seen it fail to connect with the correct credentials before. That hasn't happened in my testing. So I can't really offer anything on that. And that message about the OTA fail means that it was connected to Wi-Fi, but it was unable to reach the server to check for updates.
Now disabled Wi-Fi and re-enable it.
Possibly he has a firewall set up that's blocking its connection, but again, I have absolutely no way to know anything about it.
See if this makes a difference. Okay, it now seems to be back on the network. I can actually ping it with a computer, but there's no web interface behind this IP address. Would be nice to have a web interface where we can change all the parameters without pulling out the mobile phone and connecting via.
So that is a good idea. That was on my to-do list a long time ago, but we haven't done anything with it. Yeah, I like that idea. I think opening the BMS's IP address should actually bring up a web interface. I'm going to make a note of that too. But adding all of the parameters and settings, it's going to be like coding a whole new mobile app, so that'll take a while. I can't promise that'll be done anytime soon, but I can do a basic some kind of basic display.
Now hang on, here it says something on the other screen. Confirm. Over the air update ready.
It reached the server.
God. But now we can actually update to 3.05 stable. Yes.
That's actually the most recent version at the moment.
Okay. Firmware update.
I hope he downloads a fresh
it is finally
data
working.
sheet to go with that, because there are some
Okay,
changes.
I think we are back in business, so we should be on a different version now. Yeah, here. 0.305 stable. August 1925. Nice. All right. Okay, let's go back in the Bluetooth app, Pathfinder
nice.
BMS, and see if there are any changes. Settings. Start. Balance.
There won't be any
voltage.
changes.
So I'm still missing the setting where I can change when the BMS actually resets to 100%.
Correct.
Because I'm not going to recharge my battery to 3.5 volts.
I think you should.
It is a 3.45 only. I'm on 0.305. So obviously this is a beta version.
No.
So Steve, if you don't mind, put a little note in here for what firmware.
Okay, I'll change that next time I update the flow chart. I'll make sure it says at the top what version it applies to.
Version this flowchart is, and then if things change, you have to update this flowchart, obviously.
Yes.
Because now it is a bit I don't know. So next hurdle is to get to the website. It's obviously overkillsolar.com. More is better. welcome Pathfinder BMS. So that's the correct website, has the correct logo. But when I go to it,
Yeah.
it only shows me this stuff
Oh
here.
my
So
God.
it seems to be broken.
It was broken. As soon as I saw his video, I checked the website and found this, and somehow, some mysterious way, the website had been hacked, and we still haven't figured out how or why, but a different plugin had been loaded with this database tool that interrupted the entire website, and I had to roll back to a backup from like 2 days before that.
$230 US.
True.
So
That's right.
if I compare this to the JK BMS, this is a 200 amp BMS as well, including a 2 amp active balancer, which costs only $77, including free shipping. Or even the version 19 of the inverter BMS, 200 amps, 2 amp active balancer, communication board, and a 4.3 inch display, $120, including shipping.
Comparing prices on these websites. See what it says right there? Save $268. The pricing on these websites is nonsense. Like, by the time you put this in your cart, first of all, you don't know what version you're getting. It doesn't have any documentation. The price, it's welcome deal. See right there, the welcome deal. They do this on AliExpress and everything else. You're logged out, and it's going to show you this ridiculously low price that you won't be able to buy it for. Once you log in, the price is going to change. So you can't comparison shop prices on a website like this. It's a bait and switch.
Active balancer, communication board, and a 4.3 inch display.
If you want to compare prices for something like this, you have to go to a real website where you can actually order it. This is like a lead generating website for the Chinese company. Go to Amazon and try to buy it and see how much it is.
$20, including shipping. The JBD BMS 200 amps 8 to 21S, including UART, RS485 and CAN communication to your inverter, $81.
Yeah, if you can figure out how to make it work.
And also least the Dali BMS with 200 amps, 16S, under $70 US, including shipping. So I'm not sure what niche this Pathfinder BMS actually fits. I can totally understand that this BMS is a bit more expensive because it is developed in the US. Everything is a bit more expensive. Now they have got the tariffs as well, so everything is pushed up. And then having to do all this stuff here, it's a small display here, but what's the display worth if you put this into an RV or a boat or something, and the BMS is with the batteries in a storage container somewhere, and the display is not even visible then, yeah? How much more is a bigger display which can be connected to the BMS with a longer cable? We can have this somewhere over here and the BMS and the battery.
So I am working on a remote display. It's going to be basically the same hardware. It's going to be like a duplicate of this display that you'll be able to mount anywhere, and it'll connect wirelessly. That is coming.
All Americans and working together also, or are you now two different parties and fighting each other like your leader wants you to do?
Yes, we are.
And I think it has some really good features, so really good ideas and
Thank
everything,
you.
like the balanced test board here with a green LED, a direct USB-C connection, built-in Wi-Fi and Bluetooth. Maybe we have to wait a couple of more firmware versions until this is actually ready and also worth $230. So I really don't want to shed any bad light on this BMS here from our friends from Overkill Solar. They have made amazing conversions of the JBD BMS in the past. And I'm still using the 100 amp Overkill Solar BMS in the top shelf battery here without any issues. In fact, it is the BMS with the best state of charge calculation of all the other BMSs I ever tested. But here, with the Pathfinder BMS,
over the years, the JBD BMS had plenty of plenty of issues with inaccurate state of charge. And with that BMS, because I don't control the firmware, and I never could get JBD to sell me the source code for the firmware, I have no idea how they calculate the state of charge. They don't know. They wouldn't tell me. I'd have to go talk to the software engineers who don't speak English. So that's actually surprising that he would say that that BMS has the best state of charge calculation. Which, good. I'm glad it works for him. That's wonderful.
I'm a bit lost. So I'll definitely keep an eye on this BMS here and see what the further development is. And if there are any major updates, breakthroughs, improvements, new features, I'll definitely let you know. And I'm more than happy to do a new video then. Yes, that's it for today. As always, guys, thank you very much for all your... I'm not up to date. Thank you very much for all your amazing support here on the channel, for buying me a beer.
Okay, well, that's the end of part 1 of his review. Okay, here we go with part 2 of Andy's review. I have a feeling this is going to be hard to watch because I already know that he's reading the wrong data sheet, and I know that he put in a bad parameter for the balancer start voltage, which is going to be part my fault because I figured out that the description of the balancer parameter was wrong in the data sheet, and I have already fixed that and published the update. So here we go.
This would make no sense. Yeah, it does not make sense at all.
He's got
that makes no sense at all.
Which makes cell 1 for some reason.
That makes no sense.
I hope he measures it.
No sense at all. In general, it doesn't make sense.
Okay, come on.
If I would have hair. Guys, welcome back to the OffGrid Garage here in super sunny and already pretty warm Australia. Yeah, guys, and after the last video about the Overkill Solar Pathfinder BMS
he has 16
review
cells
and
hooked up
test
now.
video, which was a bit of a strange BMS, I think, and the software is a bit clunky, so it took me a few hours to do just the basic stuff with this BMS. But I want to follow up with this video again here, and especially I want to have a look at this charge cycle, because this is something Overkill advertises for this BMS, that it has a dedicated chip just for the state of charge measurement, and it is supposed to be very, very accurate.
It is supposed to be very accurate according to Texas Instruments, but it doesn't work right. So unfortunately, if Andy started with the right copy of the data sheet, he would have known that I already programmed an alternative to this. This learning cycle is going to go away.
Can test this here, I don't know yet. So to do this capacity learning cycle, it is fairly easy to follow these 7 steps in the manual. So we basically start with discharging the battery now to under 48 volt and then wait for the rest bit to set. Yeah, so basically the BMS, this special big huge chip there, it looks for a stable voltage under 48 volt for quite a while, and then it says, okay, we are down to 48 volt, we are not charging or discharging any further. I'm considering this as the 0% state of charge threshold. And then we basically do a full charge of the battery until we hit 56 volts or more, and let the battery rest there as well. Yeah, make sure it is fully absorbed at this specific voltage over 56 volts, and so the chip can see it is not taking any energy and the voltage is stable. I consider this as 100% capacity of this battery. And then afterwards again we do a full discharge to measure the capacity we get out of the battery, and wait again under 48 volt until the rest bit sets. So it's basically charging, discharging, and it measures the capacity in both ways and sets the parameters accordingly then. So a fairly easy step actually.
Now that sounds simple, and the way he described it is actually how the new algorithm works, the simple one that I programmed into the user interface controller. When you initiate the BMS, it's going to start at 50%, and then when you get above the upper voltage threshold, it sets 100%, and then when you discharge it all the way below the lower threshold, then it saves the measured capacity information, and it'll report 100% confidence. And there's no time limit and no specific procedure that you have to do. You don't have to get there all at once, and you don't have to do the charge and discharge at a specific rate. It's just very basic. It's gonna pick out 0% and 100% by voltage, and then during the middle of the cycle, it counts charge going in and out of the battery and reports the percentage based on that.
Not much different to what we would do with other BMSs as well. Yeah, we do a full cycle, but most of the other BMSs except JK use the over voltage protection for 100 and under voltage protection for 0% state of charge. And we know
right, these parameters are hard coded right now, and they are set. They are specified in the datasheet. I'm not sure if they're specified in the version that he's looking at, but they are now. Next time I introduce, or next time I push a firmware update, the high and low SOC set points will be adjustable.
now the JK BMS has its dedicated settings for 100 and 0%. And as far as I know, the JK is the only BMS where you can actually define these 2 points independent of any other protection voltage of the BMS.
I didn't know that.
So, yeah, I connected the Pathfinder BMS to our 16S 5 ampere hour 48 volt battery here. And because we had issues with this battery before, yeah, with the internal active balancer, which was pulling down the voltage of 2 cells to almost 0 volts here. So I disconnected this internal balancer completely from this battery, and I haven't used this battery since, basically. And there was still a bit of an imbalance there, yeah? Which Overkill Solar says you should not have. You should balance your batteries first before you do the cycle, yeah? But I wanted to find out what is going to happen if we don't do that. So, and of course I ran into the problem that one of the cells, cell number 1, was really low in state of charge when I did the learning cycle with the Pathfinder BMS. No big deal, because we have another big powerful balancer with the Pathfinder BMS, a 1 amp passive balancer. And if I set the balance start voltage a bit lower to say 3 volts only, it would start depleting all the higher voltage cells until they were all the same level as cell number 1. Problem solved. Well, here is what I found yesterday.
Right, no, that's how the manual described it. But that was actually a mistake. The operation is actually kind of opposite of what he just said.
So we now have the problem.
So that's my fault.
That we've got a cell under voltage protection of the BMS. Cell number 1 is extremely low at 2.5, 2.6 volts only. So the whole learning cycle has now completely stopped. Yeah, it didn't go ahead. It didn't proceed. I probably have to turn on the balancer and deplete all the other cells. So we're doing a bit of a bottom balancing first now. Okay, let's set the balance start voltage to 3 volts.
Yes, you could do that. I don't think you should do that. If you have a severely out of balance cell, especially one cell that's very low, you really need to charge that one cell to match and not try to have the balancer bleed off. I mean, in that situation, if you wanted to bring the whole battery down to 2.6 volts, you're asking the balancer to bleed off the entire capacity of the other 15 cells, and that's going to take, well, if it's a 100 amp hour battery, it's going to take not 100 hours, it's going to take longer than that, because the balancer can't do all the cells at the same time. I think the maximum it could possibly do would be 8 cells, because it won't do adjacent cells. So you're looking at least 200 hours to be able to fix that. So that's not the right way to do it.
Which is ridiculous.
Wait, what's ridiculous?
And okay, let's set the balance start voltage to 3 volts, which is ridiculous.
Well, you're the one with the
see if it actually
2.7 volt
balances.
cell.
You should balance all the cells but cell number 1. Okay, delta balancing 20 millivolt. Yeah, we certainly have that.
Yeah, it's not going to work.
Yeah, 440 milli. and the balancer is not coming on for some
This is
reason.
hard to watch.
So it says here on the BMS itself, learning cycle started.
I wish
and
he would
it
have
is
just
still
asked
waiting
me
for the rest. We can see the internal
advice
balancer
during
is
this
coming on
process.
as well now. The 4 LEDs. So I'm not sure why it now kicked in and before it didn't work. Or do all the cells need to be over 3 volts to activate the balancer?
Yes.
This would make no sense.
Well, that's the way.
This would be a total fail of the balancer design.
That is exactly how the Texas Instruments chip works. All the balancer functions are controlled by this chip, the BQ76952 by Texas Instruments.
If I would have hair.
If autonomous balancing is enabled, the device allows balancing if the minimum cell voltage is above cell balance minimum volts, and that's the setting that Andy is setting there on the Pathfinder BMS, and the difference is greater than the delta. So that, and there's no configuration options available in this chip. That's the only way it works. So I would have to disable the automated balancing in the Texas Instruments BMS chip and send my own commands if I wanted to change that behavior.
And then guys, the heat this BMS radiates while balancing is insane. So the Pathfinder BMS is now balancing for 15 minutes, I would say. So I was curious to see what temperatures we are expecting. And we are talking about 55 degrees. What's the back like? So this is the whole back. And we are measuring over 60 degrees Celsius.
Okay.
This is just the surface temperature of the passive balancer down there. Here as well, 50 degrees. Wow, it gets really, really hot.
Right.
Yeah, I can barely put my hand under this BMS now. And it is super hot, so 50, 60 degrees. Imagine you put one of these BMSs into such a case together with the cells. You heat up the whole battery. Tell you, a passive balancer in 2025 makes no sense. So
I disagree. It's inexpensive. I tried putting together an active balancer that was programmable to whatever delta you wanted to set it to, and the cost of it was very high. And so I just put that aside. I put that design on the table and put together the passive balancer, which I think it works really well. And you can, I mean, he doesn't like the heat that's coming off of it, but it's exactly, you know, how it's supposed to work. You're dissipating 1 amp from each cell. It's about 3 to 4 watts per cell, and it's going to get hot. And it has thermal fuses built into that base, so it can't get much hotter than what he's seeing.
when we connect this BMS for the first time, or when you start it up here, so there's a standard configuration file it loads when it starts up.
Yes.
So then when you do changes, when you change the balance start voltage, for example, or the delta voltage for the balancer, and save these information back to the BMS, and then do another start of the BMS, another restart, it loads the standard configuration file again, and it forgets the settings you have already changed.
No.
I found this 3-4 times.
If you do the full factory reset, it will reset all the settings. But if you do just a power off reset or a basic restart from the menu, it will remember all your settings.
Here with this BMS now that I had to re-enter the 3.45 volts.
Oh, if you change your cell count. If you change your cell count, that's the same as doing a full reset. It'll overwrite everything because the BMS assumes that you've transferred it to a completely different battery.
This BMS was now, well, sitting here and balancing for an hour or so. And we can again see that we are having 24, 18, 24 milliamps of discharge current. Even there's nothing.
I should probably just increase the deadband to about 50 milliamps on the current sensor. Maybe I'm trying too hard to get precision at a low current. There's an adjustable deadband that I think I have set to 12 milliamps.
Connected to it. There's nothing connected. Look at this. But the BMS claims we are discharging. Why?
Yeah, it's really difficult because it's an analog circuit, and it has to measure up to let's see, it measures accurately up to 400 amps, and so you ask the same circuit to measure 12, 20 milliamps and 400 whole amps at the same time. There's a lot of noise floor, and yeah, I should just increase the deadband.
And then this constant entering of this passcode when you go into the settings. Constantly. Not only once when you log into the BMS. No, every time you come from the dashboard, go into the settings, it asks for this passcode again. That drives you insane.
Okay, the passcode is there because a lot of people use a tablet or a phone that's stuck to the wall and it's always monitoring their BMS. And so having the passcode always come up when you switch to the settings page is to prevent tampering, basically to prevent tampering from children who would be playing with the tablet. So if that's always available, you know, if you can just go in and change the settings anytime you want, then you know, anybody that's playing with the tablet on the wall could change your battery.
Settings are not again this passcode. So what?
The other thing you could do is you can change the passcode to a single digit. You could just change it to 1 if you felt like it.
What does it think? Oh, it wants the passcode again. There's also something positive to report on.
Really?
So in the next step, I connected the BMS via MQTT to Home Assistant. And I want to show you what Home Assistant actually shows. What kind of entities does this BMS expose to Home Assistant? So let's go into MQTT, and even the setup process was a bit weird here because you have to provide the IP address of your Home Assistant, obviously, the username and the password, which I did, and it wouldn't connect. It said something like username and password rejected. Wouldn't connect. Of course you ensure
it has to be the username and password for your MQTT broker. I don't know how he has it set up.
Username and password is 100% correct. Didn't want to connect. Fourth time lucky. All of a sudden, BMS connected. Didn't change anything.
I don't know. Okay, if he didn't change anything, I don't know what's happening. I'm starting to think that his network has a firewall or something set up. I don't know, because this doesn't happen to me. I've never in all my testing, I've never seen either the Wi-Fi or the MQTT fail to connect with the correct credentials. It works every time if you're on the Wi-Fi network and you've put in the correct credentials, but he's having this problem where he tries it 3-4 times with the same credentials and then it connects. I can't duplicate that in my shop. I don't know.
The settings, it just connected. So very similar experience to the Wi-Fi connection we had in the first video, when it took like 3-4 attempts as well to finally connect to the Wi-Fi. Even all the settings, all the parameters were correct.
Has anyone else had that problem?
Here, it shows up as the Pathfinder BMS.
Beautiful.
So, we got the battery voltage of 49.86 volts, cell number 1 to cell number 16, very nice. Cell delta, the current. Let me see if I can turn off the charge MOSFETs here via the BMS. Toggle charge FET, yes. Okay, they are off now. Does it change here? Ah yeah, here. FET status charge. So this is obviously the MOSFETs themselves. But what is this one here? Discharge switch status. This is for the switch. This is the mechanical switch you can connect to these two pins on the BMS, yeah?
Beautiful.
To turn off the discharge when you connect an inverter, for example. This is what it exposes here. Okay, toggle again, so I turn charging back on again. Here it comes. Okay, this wasn't quite clear what this actually means. This is the physical switch you can connect. Okay, perfect. Highest cell, lowest cell, all the temperature probes we have here. the power, remaining capacity, state of charge, obviously, state of charge confidence, you can see here in Home Assistant, state of health, and time to empty, time to full. So all the important data you've got in Home Assistant straight away here. So this is pretty cool. Then a few diagnostic stuff like Bluetooth connection, MAC address, signal strength here, cell counts, Wi-Fi, signal strength, and so on and so on. So this is actually a pretty cool feature I very much like. And a very easy setup. You just put the IP address, username and password in, then you try to connect a couple of times, and once it's connected, it publishes automatically as Pathfinder BMS in your MQTT in Home Assistant. And now you can do all kind of automations here, can turn on loads and all this kind of stuff. So that's pretty cool actually. Overkill Solar. Steve, well done.
Thank you.
Okay, let me pull up my notes. Temperatures, cell voltages, all cell voltages, battery voltages. This one, for example, yeah? What is the BQ cell stack? Sum of all cells. Why is this different to the cell stack? What is...
This is a good point. I should bring up this screen and put a call out on each line and describe what each of those values means.
The Z100 voltage. What is the B plus terminal voltage? Load detect voltage. What is all that? Nothing explained in the manual. Zero.
Sorry
Here,
about
another
that.
one. Raw current. BQ. 0, 0, BQ average. Z100 negative 18 milliamps. Z100 average negative 12. What is all this information here? Is this a leftover from developing this BMS or something, like a developer values or something, which...
Kind of, but I wanted to include all the raw values available on the screen. Part of it is for troubleshooting, and part of it is just for providing all the information. But he is right. I should have a section in the manual that has a call out for each of those to define them, and I didn't do that.
Needs a lot of work. Someone actually left a comment under the last video and said, this is the beta version which comes already with a lower price. Once this BMS is finalized and the documentation and everything is worked out and ready to go, the price will be actually higher. I cannot imagine that they will sell this BMS here for 300 or 350.
No, the price was $199 during the pre-sale, and then after it was actually in stock, then I raised the price to $230. I don't expect the price to go up beyond $230 unless we're considering the new active balancer.
Overkill Solar in Florida. All the best with this BMS here. I hope you've got enough feedback now to keep working on it. And from what I've heard, Steve has been seen in downtown Los Angeles selling the Pathfinder BMS out of his RV to his new customers in California. So all the best, Steve.
What?
Thank you very much. And
I have no
guys,
idea what
as
that
always,
means.
thank you so much for watching. Thanks. Bye-bye. Tell you, a passive balancer in 2025
There's more.
makes no sense.
All right. Well, okay. That was kind of hard to watch.
Overkill Solar. Steve, well done.
Thank you, Andy. Okay, so I think we're done with the reaction video here. If you've watched this whole video all the way to the end, I'm amazed and impressed. So here is a coupon code. I'm going to put up I think I'll put up a $50 discount for the first 10 people who use this coupon to buy a Pathfinder BMS. So that's just my thank you for the 1 or 2 people out there that are going to watch this whole thing all the way to the end. And I'll see you later. Bye.
Well done.